Okay, in this video we're going to talk about derivatives. We're going to have a basic introduction to derivatives and the rules that you need to know. Okay, so let's look at this graph. Now, we know that the slope of a line is constant. Okay, but this is not a line, this is a curve, and so the slope is different at every point on this curve. So how would we go about finding the slope of this curve? Well, we have some options. This is called a secant line. And it's called a secant line because it hits the graph in 2 points. And if we found the slope of this line between this first point and this second point, we would have what's called the average rate of change, okay? But that's not what we're looking for. We want to find the rate of change or the slope at a specific point. So for example, if I wanted to find the slope at exactly the point 1, what I would actually need is the tangent line at that point. And so this is a tangent line. A tangent line is a line that hits the curve at exactly that point, exactly that 1 point. So they share this point. And so if I find the slope of this line, this tangent line, then I have the slope of this curve at 1. Okay, so that's our goal. Now, we can find the slope of a line using slope formula if I have some good points, or we could count it, rise over run, but we're going to look at another option, and that's what our derivative is going to be. So what we need to remember is that when we talk about the gradient of the tangent line, and gradient means slope, when we talk about the gradient of the tangent line, that is the same as the gradient of the curve at the point they share. Okay, so that is super important for you to memorize. Okay, so now we just want to look at what are some examples of derivatives, what are our derivative rules that we're going to be using here at the beginning. So these are our basic rules. So if you look at this one, what if I have y equals x to some power, and we're just using n to represent some power? So what I would do is I would multiply that n by what's in front. In this case, there's a 1 in front, so that n you see here is going to come down in front, and then we have to always remember to subtract 1 from our power. So this would be the notation. Now this right here reads dy over dx. Okay, we'll say dy dx. And that is just the notation for the derivative of y with respect to x. So I don't want you to stress too much about it. If I'm taking the derivative of y, this is the notation that tells me that I'm taking the derivative of y with respect to x. And so again, the n came to the front, and then we subtracted 1 from the power. So let's look at what that looks like. Here's our example with y. So we're going to say dy dx when we take the derivative. And this 3, because there's a 1 in front there, this 3 is going to come to the front. Technically, we're multiplying 3 times 1. And I am going to subtract 1 from that power. And so 3 minus 1 would be 2. So I would really write dy dx equals 3x squared. That's my derivative. Okay? Now, on this one, I did give you a different notation because I want you to get used to seeing both. This reads f of x equals x to the 8th power. If we take the derivative of f of x, we use this notation with this little apostrophe here, and that reads f prime of x. And that still just says I took the derivative of f of x. So f prime of x is going to be equal to, remember the 8's going to come to the front, and then I'm going to subtract a power. So 8 minus 1 is 7. And that's my derivative. Okay, let's look at this next rule right here. The only thing different is that we have this k in front, and in this case I'm using k as a constant, as some number. So if you have a number in front, what happens is that n actually gets multiplied to that number, which you can see here, k times n, and then we still just subtract 1 from our power, like normal. So let's look at these examples. Here I have y, so if I take the derivative of y, I'm going to write dy dx. And then this 3 is going to get multiplied by 5 first, so 3 times 5 is 15, and then I'm going to subtract 1 from my power, which is going to give me x squared, and that is my derivative. Looking at this example, I have the notation f of x, so I'm actually going to write f prime of x, and you just got to get used to that notation. And then this 6 is going to get multiplied by this negative 2, which is going to give me negative 12, and then I'm going to subtract 1 from my power, which is going to give me x to the 5th. And that's really all there is to it, guys. We're going to look at this last example here. So what if y equals k? Remember, k is a constant, so k is some number, any number. If y equals a number, then dy dx, or the derivative, will always be 0. And that should make sense to you. And let's look at this example, because if I have y equals 7, think about what that looks like on a graph. Well, That's a horizontal line at y equals 7. And if that's a horizontal line, the slope of that line is 0. Guys, and that's what the derivative is. The derivative is your formula for finding slope of any curve. Okay, so if I have a line that's horizontal, the slope is 0. So we just put dy dx equals 0. Notice there was no x to subtract from or anything like that, so it's just 0. Same thing over here. This is f of x. We're going to write f prime of x, but this -5 is just a constant. That tells me I have a horizontal line and the slope is 0. Okay? Okay, so we're just basically going to look at some more examples, several examples. I'm going to do some and I'm going to ask you to do some. So this says differentiate, which means find the derivative, okay? So don't get hung up on the wording. I can ask you to find the derivative, or I can say differentiate or derive, okay? And so look at number 1. Now we just have, I gave you some basic examples, but now we have two things going on here. So I'm going to say dy dx equals, I'm going to take the derivative of this, which would be the 2 getting multiplied by the 3, which would give me 6, and subtracting 1 from my power, which would give me just x, or x to the first. Then I am going to look at this one, and I'm going to say the 4 is going to get multiplied by the -6, which will be -24, and I subtract 1 from my power, which gives me x cubed. That's your derivative, okay? I want you to take just a second, I want you to pause the video, and I want you to try number 2. Okay, so again I have notation f of x, so we're going to write f prime of x. And here, you can put a 1 there if you want, but the 2 is going to come in front since it's just a 1 there. So 2x, and then I'm going to take the derivative of this, which is just going to be, that's a 1 there. So technically what you're doing is 1 times 3, which is 3, and when I subtract 1 from the power, I get x to the 0, so the x goes away. And remember that the derivative of any constant is 0. So the derivative of -4 is 0, so I'm not going to write plus 0 out here. I just have 2x plus 3. That's my derivative. Okay, on this one we're going to write g prime of x, and this is just a constant, and anytime I see a constant, just like we did up here on number 2, the derivative of a constant is 0. So that's my answer. All right, I want you to pause the video, take a minute, think about number 4, and try that one. Okay, on number 4 we're going to say dy dx equals, and guys, pi is just a number. We know it as 3.14. There's a lot more to that, but pi is just a number, and so the derivative is 0. Okay? All right, we're going to look at a few more examples that get a little bit more complicated using things that you already know. So here on number 5, I see that f of x is equal to 2 times the square root of x. Well, we need to rewrite that, and you guys know how to do that. So the first thing I'm going to do is I'm going to rewrite this as 2x to the 1/2. So I want to rewrite my radicals as fractional powers, okay? And now I'm going to take the derivative. So I'm going to say f prime of x equals 1/2 times 2 is 1, so you can write the 1 or not, and then I'm going to have x, and I'm going to subtract 1 from that power, and 1/2 minus 1 is -1/2. Now, that is your derivative, and that is fine. However, if we're going to do math with this, which is coming, and I'm going to be plugging in values or solving, then it's going to be easier if you rewrite this without that negative exponent. So I would say f prime of x is equal to, and I would put 1 over, and now I have 1 over x to the 1/2. And that would be sufficient. You could also write 1 over the square root of x. Those are the same things. Okay, so I want you to know how to find the derivative, and I want you to know how to manipulate it to write it in a form that's easier to work with. Okay? All right. On number 6, here's our problem here. Okay, so this is different than we did previously. I have an x on the bottom. So what we need to do is we do need to rewrite this as y equals. We're going to leave the 3x alone for a second, but we're going to bring this x to the top. I want you to think about, how did we do that? We take 2 and we go x, and since that's an x to the first, on the bottom, I want to bring it up to the top. It's going to be x to the -1. Okay, so now I want you to pause the video and take that derivative. Okay, so it's y, so we're going to write dy dx. We're going to take the derivative of this first term, which is 3. But now when I take the derivative of this, I've got -1 times -2, which is going to be a positive 2x. And when I subtract a power, I'm going to get -2. So be careful to make sure you watch those signs there when you're subtracting. Now, This is fine for me if I only ask you for the derivative, but we're going to be doing math with it, so I want you to get used to rewriting this in a form that's easier to work with. And if I do that, I'm going to leave the 3 alone. Here, I'm going to leave the 2 alone, but this has a negative exponent, so I'm going to bring that to the bottom as x squared, and this is the derivative. Okay? All right. Looking at number 7, you have a couple ways to do this. A lot of people like to bring this x up to the top as a -1 and distribute it first, which is fine. The problem I find with that is that when you have a number in front, like this number 8 over here, people often accidentally goof with that number and don't follow the rules. So what I would suggest to you is if you have a single term on the bottom, is to break this up into 3x squared over x, and then -2x over x, and 1 over x. So all I did was divide each term on the top by the x, and I broke it up. Now I'm going to rewrite it by simplifying them or moving things around. So 3x squared over x is just 3x. And -2x over x, the x's cancel, and I just get -2. But this one, remember, we don't want an x on the bottom, so that's x to the first, and we're going to move it to the top by making it 1x to the negative first. And now I have something that looks pretty normal, and I can take the derivative of that. So dy dx is equal to, now here I'm going to have the derivative of 3x is just 3. The derivative of -2, which is a constant, is 0, so I'm not going to write that. But the derivative of this is going to be -1 times 1 is -1x to the -2. And again, probably for now, you should rewrite that for practice. And I'm going to leave my 3 alone. I'm going to leave my -1, but this x to the -2 is going to come to the bottom as x squared. Okay, so that's my derivative. All right, on number 8, it's very similar concept, but we do need to rewrite the bottom first. So I'm going to have 2x to the 5th minus 2x cubed on the top, but we want to write this without that radical. So the 3 is going to stay 3, that doesn't change, and I have x to the 1/2 because that's what a square root is. So now I'm going to break this one up just like I did the other one. I'm going to take this 2x to the 5th and put it over 3x to the 1/2, and I'm going to take this 2x to the 3rd and put it over 3x to the 1/2. And now I'm going to simplify. So here, when I simplify, I'm going to leave the 2/3, but my x's, this is going to be 5 minus 1/2. And 5 minus 1/2 is going to give us 9/2, so x to the 9/2. Here, I'm going to leave the 2/3 here as well. And I'm going to have 3 minus 1/2. And that's going to give me x to the 5/2. Now I can take a derivative like normal. So we're going to write f prime of x, and 9/2 times 2/3 is really just 3, so that worked out nicely. X, and when I subtract 1, I'm going to have 7/2. Okay, so just be careful with that and check the math with a calculator if you need to. Here, 5/2 times 2/3 is going to be 5/3. And then I'm going to subtract 1 from this, which is going to give me 3/2. Okay, and so that's my derivative. And that's all I need to do. All right? Okay, we're going to look at just a couple more examples. And this is important. Here we're finding the gradient of a curve at a given point. So now we're not just finding the derivative, we're using the derivative to find the actual gradient or the slope. So find the gradient or slope of the curve with equation y equals x squared minus 4 at each of the given points. Well, the first thing you always need to do is you need a derivative. So dy dx of this. The derivative of x squared is going to be 2x, and the derivative of 4 is 0. So this is just 2x is my derivative. Notice that there's an x there. There's no y. dy dx is not y, okay? So I can't plug in a y value. I can only ever plug in an x value to a derivative. And so I'm going to take this derivative, my dy dx down here, equals 2x, and I'm going to plug in this 1, okay? So I might write dy dx, and then this would say at x equals 1, and that's just notation to say that we're plugging in 1. And when I plug in 1, I get 2 times 1, which is 2. That's it. I didn't even have to worry about the y. And so sometimes you're not given the y. Notice that B says find the gradient of the curve at the point where x equals -3. They only gave us x equals -3. But again, I'm going to say dy dx, and I'm going to evaluate that at -3, is equal to 2 times -3. And then 2 times -3 is just -6. Last thing here I want to show you is we're going backwards now. Finding coordinates when given the gradient, if you're given the slope. So this says find the coordinates of the point on the curve, this curve, 3x squared minus x, at which the tangent to the curve has a gradient of 11. So gradient of 11 is my slope, and the tangent, remember, will have the same slope as the curve. So they've given you the slope of the tangent, which is going to be the slope of the curve at their shared point. And their shared point is what we're trying to find. So we have y equals 3x squared minus x. We always need a derivative first. So dy dx equals, the derivative of this is going to be 2 times 3 is 6x, and I subtract a power, which just gives me x to the first. And the derivative of this, you can put a 1 here, is going to just be -1, because I'm going to multiply or bring that 1 to the front, but when I subtract 1, the x goes away. So if you just have x to the first, when you take the derivative, the x is not going to be there anymore. This is my derivative. Now, it didn't give me an x value to plug in like the last example. What it gave me was a gradient or a slope. And the only place that that can be plugged in is into dy dx, because dy dx represents slope. So I can plug 11 in here and set it equal to 6x minus 1. And then I can just solve for x. So if I add 1 to both sides, I get 6x equals 12. I divide by 6. I get x equals 2, and that's great. If it had asked me for the x value where this happened, or where the tangent had a gradient of 11, but it asked me for the coordinates. So I need to go find my y value that goes with that. I need to do 2 comma, and I need a y value. And to do that, we always go back to the original curve. Guys, that's where you always find y values. You take your original equation, and you plug in your new x value that you found for every x. And so this is going to give us 2 squared is 4 times 3 is 12 minus 2, which is going to give us 10. So the y value that goes with that 2 is 10. And this is the shared point where the tangent has a gradient of 11, and so the curve also has a gradient or slope of 11. Okay? I want you to try these 3 problems in your spiral. I just want you to try them, and you can go back and look at your notes, okay? So take a minute and pause the video, and then I'll go over them. Okay, so on number 1, we are asked to find the derivative at the given point, so we just need to take the derivative first. And when you do this, 3 times 3 is 9. We're going to have x squared because we subtract a power. The derivative of -2x is just -2 because when I subtract a power, the x goes away. And the derivative of 1 is 0, so we don't need to write that. I now just need to plug in my x. So dy dx when x equals 2 is going to be equal to 9 times 2 squared minus 2. 2 squared is 4 times 9 is 36 minus 2 gives us 34. So that is the derivative at the given point. Okay, and remember that means that that's the slope of the tangent at that point and the slope of the curve at that point. Okay, here we have f of x equals 3 over x plus 2x. So our first step is to rewrite this without that x on the bottom. So this is going to be 3x to the -1 plus 2x. Then we want to take the derivative, which is going to be f prime of x. This is going to be -1 times 3 is -3. X, we're going to subtract a power, which gives us -2. And then the derivative of 2x is 2. Now, we probably should rewrite this as -3 and bring that x to the -2 down to the bottom so the power is positive. Rewrite it like this, and then we need to plug in our 1. And so in this case, I can just write f prime of 1 to show that I'm plugging it in is equal to -3 over 1 squared plus 2. And this is just going to be a 1, so I'm going to end up with -3 divided by 1 is -3 plus 2 gives me -1. And that is the slope of the tangent line and the slope of the curve at the point where x equals 1. Okay? Last one, find the coordinates of the point on the curve, y equals 2x squared minus 5x plus 3, at which the tangent to the curve has a gradient of 3. Okay, so still the first thing we need is the derivative. So the derivative here is going to be 2 times 2 is 4x, and I'm subtracting an x, or a 1, which gives me just x. The derivative of negative 5x is negative 5, and then the derivative of 3 is 0, which I don't need to write. Now, I don't have an x value to plug in, so the only other thing that I would be allowed to plug into this equation would be the slope, and they gave me slope, gradient of 3. So that goes in place of the dy dx. And then we solve for x. That's going to give me 8 equals 4x, and so x equals 2. However, we want coordinates, so you can't forget to go back and find the y. And then remember, once you have an x, you go back to your original curve, your original equation, and you plug that x in so that you can find the y value that goes with it. So we're going to have 2 squared is 4, times 2 is 8, minus 10, plus 3. And so y here is going to be 8 minus 10 is negative 2, plus 3 is positive 1. So I'm going to have the coordinate of 2, 1. And that's my answer. That's the coordinate where the gradient or slope is 3, and this is the slope of the tangent and the slope of the curve at this point which they share. All of those connections are going to be super important. So I need for you to write those down or make sure that you know those. Okay? Go back and review what you need to review on this video, and I will see you in class.